stoichiometry. It is spelled like this. Stoichiometry. Now, stoichiometry is basically this. Up to this point, we've been balancing chemical equations, we've been trying to figure it out, but I have not told you at all what it's actually useful for. So, let us take a sample chemical equation, such as this. That's a Q.
Why is there
Whew! All right, so this is a chemical equation.
What's the dot? Right there.
That is a hydrous compound, so it has water that just kind of hangs out with it.
Is that what the dot means?
Yeah.
Okay.
not multiplication?
No, it's just that. Now, this is horrible, right?
Mhm.
And up to this point, your homework assignment would have been to balance the chemical equation. In fact, let's just do it for fun. I've given you one number, which should help in the analysis.
Oh, you're doing it right now?
Yeah, why not?
Oh. I forgot how to do this.
Balancing the chemical equation.
Oh.
You guys were promised a quiz this week or a test?
Quiz.
Sorry, sorry.
Quiz.
It was a quiz.
Quiz. More tests.
It was-
Quiz.
You just had, no wait, you just had a quiz, so it's a test.
Oh,
That's
it
right.
was like a practice.
Every other week, so,
Tests are better than quizzes.
No.
notes on this number only applies to this one. So this is one thing and then that's something else. It's just attached. So, how do we solve this? Well, I need to go and look for, again, those similarities. So I see an SO4 here and I see an SO4 there, but I see no other sulfur. So I know that these two numbers must be the same. I also see calcium here, and the only other calcium is also that one. So these three numbers must be the same. Okay? Unfortunately, this doesn't balance, right? So maybe we'll try 2. And what does that give us? Let's write everything out painfully. How many calciums? 1. Good job. Phosphorus? 2. Oxygen?
A, 6.
5.
13. Hydrogen? 4. Sulfur? 1. This side? You gotta breathe, buddy. You gotta breathe. Face is turning red.
Oh my gosh, it really is.
Wow.
You must breathe. Breathing is. Oh, that's
No one
it.
needs an airbag.
No one died again. Do you know what an airbag is?
Oh wait, I meant like you know the paper bag that they use in school?
Oh, like an airbag, not a like.
No.
Airbag. Yeah. Calcium, 1. Phosphorus,
One.
with a 2 there, 2. Oxygen,
4, 10, no, 14.
Wait, actually.
18.
What? Wait, I don't see the other.
4, 8, 12, plus 6 is 18.
How'd you get 6?
That was given.
Oh, yeah.
No, but it's 6.
Oh,
6 water, yeah.
Oxygen.
Okay, hydrogen, 6 plus 12 is
I
also
still don't
18.
understand how that's 18.
Cause.
And sulfur is 1.
It is what it is.
Because there are
Yeah, 18.
8 here.
Oh,
There's
there's
4
two.
here,
Never
and
mind,
there's
never mind,
6.
never mind. Okay, I got it.
6 plus 4 plus 8 is 18. Yes.
Did you explain what the dot was?
It just means that it's attached to that thing, but
So why isn't it plus?
because it's attached. So this is one molecule, like the water has like attached itself to that.
So if you put a 2 in front of there, it's not gonna be like,
It's only gonna apply to this.
cool.
Yep. Okay,
Oh, wait, I have a question.
yes.
So, where did you find the two P's? Potassium.
I'm guessing,
Phosphorus.
because phosphorus, there's 2 of them here, so I needed 2.
Oh.
Yep. Okay, good question. So let's go through. This, good. This, good. This, horrible. That, horrible. This, good. So what is the knob I can change?
Well,
H2O,
Oh.
right? Oh. 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 Okay, how do I make 4 into 18?
You do 2 on.
Did she say you pray? That's right. Jesus is always the answer.
Don't you do
Maybe put 2
double?
on H2O.
Do I what?
Doesn't 2 go on that?
Oh, 9.
no, not 9.
Put 3.
I'm confused.
No, I was trying to find the most common multiple.
2, 2,
Okay, 2 gets us to 6 and 14. 3 gets us to 8 and 15. 4 gets us to
Oh, you know what? Just go to
10. 5 gets us.
How are you
Go to
doing this?
6.
Yeah,
Go to 6.
because he's
An
engineer.
He's an
engineer.
5 gets us to 18 and I'm adding 1, aren't I? 17 and 12. And 6 gets us to 18 and no. Yeah.
Let's go.
Okay.
Wait, so how did you do that? Could you do that again?
I just kept adding them until anything matched.
So by what number then?
By 1.
By 1?
Yeah.
Then wouldn't it stay the same? Oh no. And then it would just change the number, right?
Yep.
But how would that like calculate into like a single number for like?
Because it changes the number of hydrogens and the number of oxygens.
So if I
What are you doing?
put 2 there, it would be like 15.
It would be 14 and 6.
You know what? You can just how? Wait, I have 2. Oh yeah, that would be
It's horrible.
15.
Yeah.
Oh okay. That makes sense.
Okay.
I'm gonna try.
Is this balanced?
No.
No, I'm
Close
missing
enough.
hydrogen.
Imagine if SAR
So,
2.
I can't get it balanced, which means I have to turn this knob. See that knob? All of those numbers have to be the same. So, let's try. Oh dear. I wrote it wrong. I quit. Okay. This is over. This is over. Okay. So, anyways, that horrible, horrible awfulness to say this. Once we have it balanced, we're not done yet. We have more suffering to do. Because now we have to figure out, and this is the whole point of your lab, how much of each reactant is needed in order to get to our desired amount of product. So let's go to a simple example. That is, okay. So we have P4 plus 5O2 makes 2 P2O5. Sound good? Now, here is the question. If I want 6 mole, what is this called? Diphosphorus pentaoxide. Diphosphorus pentoxide.
Times
Wait,
2.
wouldn't it be?
Thought it was option.
Oh, because you don't do that.
Decaoxide.
No, you don't include that. There's 2 of this molecule, which is diphosphorus pentoxide, and I just have 2 of them. Good question. P4O10 would be something else.
Okay. That equation's already equal.
Yes. So, what if I wanted 6 moles of diphosphorus pentoxide, and I wanted to know how much P4 was required? P4. Optional B again.
So right now there's 6 moles. I mean 2 moles.
I want 6 moles diphosphorus pentoxide, and I am asking how much P4 is required. Now here's how you're going to do it. This is a unit conversion problem. Doesn't look like it, doesn't smell like it, but it is. Are you ready? 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 I can't hear you. Oh. Okay, we're not doing it. So, this is a unit. He's gone again. It's always someone. Is it? Okay.
Very high.
So, we need to talk about a good sleep balance, because our class has dissolved into uncontrollable laughter, not once, but twice in the last week. So let's talk about a good sleep balance. Sleep is important.
5 hours.
Video games
Tops.
are not important. You are building a virtual world. That could be true. You are building a virtual world and racking up achievements that account to very little. I know.
Because we are
As of
depressed.
late, I have been playing the Animal Crossing. And I know
That was so
that
bad.
all of those fish that I am catching, they don't matter. The bridges I'm building, the home that I'm constantly upgrading and never content with, it doesn't matter. But
You want to put that on your
if I get a good night's sleep, I could if I was a software engineer.
But we are depressed.
But if you get, but if I may, perhaps one of the reasons that the sorrow and the uncontrollable laughter and the drowning our cares in video games or street racing, if I may, with your not street raceable or raceable at all cars, could be
Okay,
that, hold on, could be that
I've been one guy so far.
we must incur the appropriate amount of rest. And when you rest, things that are not funny are still not funny. But when you're tired, like at the lock-in in 2 a.m, when I walk in, I'm like, hey Michael, I was 6 afraid of 7. He's gonna break out loud, he knows the answer. He's gonna lose it. It's not funny. Because 7, 8, 9. And then look, let all God's people who have not had enough sleep say amen. No, just kidding. All right, so
I did 70.
let's sleep. Everyone, get good sleep tonight so we can proceed with life later. Okay, back to the lesson. We want 6 moles of diphosphorus pentoxide. I am trying to work my way from this quantity to this quantity. do we have a recipe, if I may? The book was encouraging us to make Rice Krispies treats. I don't know if we should.
Anyone can cook.
We should
Oh,
have
that could be our next week lab if we make it through this one. Do we have a recipe for the number of P4 required to make diphosphorus pentoxide? Oh, let's look at the board and see if we can find it. Oh, hey, there's a recipe right here. It says that 1 mole of this makes 2 moles of that. Yes? So I'm going to treat that recipe as a conversion factor. 2 moles diphosphorus pentoxide per 1 mole phosphorus gets me the result that 3 moles of phosphorus are required to make 6 moles diphosphorus pentoxide. Now, I would like all of you to figure out how many moles of oxygen would be required for the same yield. Go.
How much
How much
would it be?
oxygen?
05?
How much oxygen is
15.
required to get the same yield? I did not get 30. Or, did you say 15? I did not get 15. I also didn't get 30.
You didn't get 15? What is it?
I didn't get anything.
Did she not like that?
I'm gonna draw this.
I want to not do a
Diphosphorus pentoxide, and then draw the thing. And then what's your recipe?
You just switched the
Oh, bird, it's flying.
No, it's your degree.
Wait, so how would I divide this out?
I don't know. I haven't done it.
My math.
So then how do you know that you didn't get 15?
I didn't get it.
How do you
I didn't
know?
say it was right or
Oh.
wrong. I just said I didn't get it.
I think it's right.
So what happens to the
How many
There,
oxygen
I can't.
do you need?
Okay, how are we gonna do this one? Same deal. We have 6 moles diphosphorus pentoxide. We are going to cancel that with the 2 moles in our recipe, or balanced chemical equation in this case. And I need to know how many moles of O2. Don't get caught up that it's O2. Until we get to the grams form of that, it won't matter. I just want to know how many of this thing I need. This is 5. Hey, it is 15. That's cool.
Oh, I just.
These cancel. And I'm left with 15 mole oxygen. So, what does this tell us? Well, if I have 3 moles of this and 15 moles of this, then I can create 6 moles diphosphorus pentoxide. It's just a recipe. In fact, if you look at it carefully, all we did was multiply this by 3. Micah, please calm down. Multiplied by 3,
Oh, okay.
right? So these are just ratios. They're not anything too crazy. You're just looking at the numbers in front of each one. Yeah, which part?
Well, how did you get 15?
Well, 6 times 5 is 30, divided by 2 is 15.
Oh,
Okay. Now let's try ugly numbers that we can't as easily figure this out. So suppose I have 28.6 moles of oxygen. How much phosphorus would be required to react all of the oxygen? And how much would it make? Go.
Phosphorus?
Yep. So I want to know how many moles of P4 and how many moles of P2O5.
Didn't you already P5? Oh, P5. Not P5, it's not P5.
Micah, please put your oxygen mask on first before helping others. Maybe yours.
Baby.
You're not doing the problem. I need to do the problem.
05? P205, right? Oh, wait, I think I know. No, I don't.
What's the,
Find how many moles of phosphorus and P2O5.
Is it
Is
5?
that two different, like,
isn't it six?
Everybody
Two?
does it.
that? Yeah, but like two thingies.
Alright, after that musical interlude, let's take a look. So, we know that we have 28.6 mole of oxygen. I want to know how many moles of phosphorus would be needed to completely react all of that oxygen in this chemical reaction. So, what is my mole ratio? Well, I have 5 moles of this per 1 mole of phosphorus. So that equals whatever 28.6 divided by. Is there a calculator thief out there?
Right there. I thought you missed
You
it.
okay, buddy?
Okay.
Go get a drink. Okay. These are exact numbers. So we're not going to include this in our significant digits, right? Because these are whole numbers of moles. It's balanced. So again, you're like counting things. Those have an infinite number of significant digits. So we don't include that. So I will report 3 significant digits. Okay, yes.
I'm confused as to why you used the mole and P4.
Because I want to know how much phosphorus I needed to react all of this.
Yes, but that doesn't.
So I need 1 mole of this for every 5 moles of this.
Mm-hmm.
So this should be 1/5 of that.
Oh, but for that one, why did you use the P2O5?
Because I was given this one.
Mm-hmm.
So I start with this one on the bottom. And I go to whatever I want.
Oh, you can just choose whichever one you want
Yep.
on top? So it doesn't matter that this is the reactant side and not.
Nope, because it's balanced. So I can use any of them. So for the P2O5, I'm still going to use 5 moles because I have oxygen, so I need oxygen. On top, I know that 5 moles of that go to 2 moles of this. So it's going to be that times 2/5. 11.44.
Oh, see, I did that, but then I put
Okay, so let's try this now. Suppose we have 123.45 mole of P4. Tell me how much oxygen I need and how much diphosphorus pentoxide I need, or I will get. Oh, that's right, buddy.
Examples for
I know.
getting into
But you said-
stoic.
You guys don't want to know what's
Stoichiometry.
stoichiometry. Yeah, right there. Everything else. Oxygen, diphosphorus, pentoxide. Okay, so mold of what? Upstairs, you want that on the bottom. Yep. And you're gonna do.
What is he asking for? He's asking for us to find 1.2 moles of
And what is this?
and I'm like,
So our conversion factor is 1 mole of that to 5 moles of oxygen. So you would do 1 here, plus 5 here. You get. We got this.
oh, yeah, what is he asking for?
So these numbers are from the balanced chemical equation.
Oh.
So it's either 1, 5, or 2. What goes with P4? What number is it going to be?
With like 2 mole, 5 on top. How do I find that number before?
And then what do you want? You either want O2 or P5. See how that works? Nope, it is that simple.
I got it. Oh, or did you? Yeah, here.
There's empty
What are you trying to find? People?
I don't know. Mr. Blenda? I need assessment.
Go ahead. Why not? This is chemistry class. You gotta come like ready for a battle.
How many moles are?
It's like you're ready to be under attack by an invading army, and you're like, I forgot my calculator.
I wish I could.
So I did.
When you did a calculator in that battle,
Every day.
I'm gonna see how far this grenade is. Math?
Okay, here we go. So, you are using these coefficients from your balanced chemical equation. That's your recipe. So anytime, right, we start with this amount. If I want to find out, I don't know, how many moles of oxygen I want, the number that's going to go with moles of oxygen is 5. Because there are 5 moles of oxygen per 2 moles of that per 1 mole of that. That's your recipe. Okay? It's like you're making cookies. It says 1 cup of flour per 2 cups of sugar, and you want to double it, it would do 2 cups of flour per 4 cups. That's how much is in cookies. It's horrible. Maybe not that
A
much.
cup of
Yeah, no.
sugar?
Is there more?
that's
Is there more sugar
A
than?
cup of sugar and then you have brown sugar.
Anyways, so I want to cancel